Doing a video solution for October exam 2022 for Year 12s. So it includes the first few chapters of Year 12 Pure Maths and also the first few chapters of Statistics and Mechanics as well. The test itself is 90 minutes and it's 1 hour and 45 minutes long. Starting with the first question over here, which is in pure maths, we've got factor theorem to show that x plus 2 is a factor, and then eventually we want to factorize the cubic equations completely. Now notice that nowadays calculators can solve cubic really quick. So what that means is if you were to solve it when y equals to 0, you could just put in a calculator and it will give you all the solutions. When I do like equation, which is in A, and then as a polynomial, which is polynomial, and then we want 3 unknowns, so that's 3. So what we can do is we can type 2 minus 7 minus 10 and then 24, them being the coefficients of 2 minus 7 minus 10 and 24 respectively. So if we type it into the calculator, we should be able to just get the root straight away. So all it means is later on we can turn it into a show that part of a question. So we're going to talk about what the common mistakes are as well, but the end of the question, if we were to actually solve it, we can see that we've got x equals to 4, x equals to 3 over 2, and also like x equals to minus 2. So if we were to go one step before that, we can have x minus 4. Notice that a lot of people write x minus 1.5, but if you do x minus 1.5, then you fail to acknowledge that the coefficient of x cubed is 2. So you need to write it as 2x minus 3 and x plus 2. Alternatively, we could write it as x minus 4, x minus 1.5. But if you do x minus 1.5, we need a 2 on the outside, and x plus 2, because that would then give us a coefficient of x being 2x cubed. But that was just like if we were to look at the last part of the question. We have not actually like gotten any mark yet towards like part A. So what are the marks to part A? Part A says use the factor theorem to show that x plus 2 is a factor. So we will need f of minus 2 equals to 0, which is 2 bracket minus 2 cubed minus 7 bracket minus 2 squared minus 10 lots of minus 2 plus 24. Notice that when I substituted in minus 2, so when negative 2 is x, or when x is negative 2, we have 2x to the 3 minus 7x to the 2 and then minus 10x and then plus 24. What we should get is 0, so f of minus 2 equals to 0, which must mean that as a conclusion step, we need x plus 2 is a factor. So in order to get the 2 marks, the first mark is the first line, the second mark is the second line. Immediately, using any method, we should be able to take out a quadratic factor, depending on what your preferred method is. Some people prefer to use compare coefficient, whereas some people prefer to use long division. My personal preference is to use compare coefficient. I'll show you both ways for this part B. So I'm going to call this way 1, which is the compare coefficient way. Now we realize that x plus 2 is a factor, so that means that x plus 2 multiplied by a quadratic, ax squared plus bx plus c, should be the same as 2x cubed minus 7x squared minus 10x plus 24. So because when we expand it, we should get the cubic. So we're finding out what a, b, and c are. So if we were to fully expand this, we have got ax cubed plus bx squared plus cx, and then we add it by 2 multiplied by everything, which is 2ax squared, 2bx, and also 2c. All of them should be the same as 2x cubed minus 7x squared minus 10x plus 24. So we can compare it and say that 2 must be A. We can compare it and say minus 7 must be B plus 2A. We can say that minus 10 must be C plus 2B. And finally, we can also say that 24 must be 2C. So what it allows us to say is that this is called compare coefficient because we're comparing each coefficient. So A equals to 2 by comparing the x cubed term. By comparing the x squared term, 2A plus B must be minus 7, which means that 4 plus B must be minus 7. So B must be minus 7 minus 4, minus 11. And then we've also got C plus 2B, it must be minus 10. So C minus 22 must be minus 10. So C must be minus 10 plus 22, which is 12. Lastly, when you look at the last term, 2C must be 24. So it's a good way to double check. We can see C to be 12. So they are consistent. That means that what you have got is that your linear factor x plus 2 and your quadratic factor must be 2x squared minus 11x plus 12. And we can easily just say that this itself would become x plus 2 and then 2x minus 3 and x minus 4. So those are your free factors or free linear factors. So that's the first way. I call this way 1. The second way is the long division way. So long division way is just a different way to take out the quadratic, in which case is 2x squared minus 11x plus 12. So if we call that way number 2, then the quadratic way would be taking out the cubic first. So this is 2x cubed minus 7x squared minus 10x plus 24. For which, when we take out the cubic itself, some people will call it bus stop method. It depends on how you want to call it. It's the same method as a whole. So what we've got is, if we call it as a way 2, then what we have got is taking the cubic first, which is this one. We want to put it inside our bus stop, and we've got x plus 2 outside our bus stop. We look at the first coefficient x, we multiply. How do we multiply to get to 2x cubed? We'll need 2x squared. Since we need 2x squared to get to 2x cubed, we're doing 2x squared multiply by both of the term of x plus 2. So 2x squared multiply by x plus 2 is going to get us 2x cubed plus 4x squared. Now, notice that these terms will need to be carried over. The minus 10x and the 24 will need to be carried over. But for now, we've got minus 7 minus 4, which is minus 11x squared. Minus 10x. So same thing as before, we need to think of how does x multiply to minus 11x squared. So we need a term which is minus 11x, which gives us minus 11x squared minus 22x. Again, the terms of 24 need to be carried over. So minus 10 minus minus 22 is going to be 12x plus 24. For which we have 2, so we multiply by 6. Multiply by 12. So 12 times x is going to be 12x. 12 times 2 is going to be 24. We can see that there's no remainder, so we have taken out the cubic out and get a no remainder. So the fully factorized form of the cubic is the same as what we had earlier, which is 2x squared minus 11x plus 12. You can see that those two are the same. So that's the way number 2. So way number 2, of course, immediately follows that we factorize the quadratic and taking out two linear factors, which is 2x minus 3 and x minus 4. Factorizing quadratic is obviously GCSE skills. So that itself would then give us what we want in terms of the answer. So you still need to do like x plus 2 multiplied by 2x squared minus 11x plus 12, and then writing down the two answers earlier, which is x plus 2, 2x minus 3, and also x minus 4. But that's it. That's question number 1. Question 2. First of all, part A is a show all stages of a working, and we cannot use our calculator technology to find out x. The main thing is because if you think about all your calculators, it has a solve button. So questions like this, you can just put in a calculator, it can solve it for you. So things like if you do like option and then calc, and it doesn't matter if you do solve n or solve. So solve will give like one answer. So if you do like 3 to the power of x and then equate it to like 1 over 27, and just say solve for x, so comma x, close bracket, automatically these can just give you -3. So so that's why we need to show all stages of our working. So what it means is, think about 1 over 27. 3 to the power of x is 1 over 27, but 27 itself is 3 to the power of -3. It's 1 over 27 because it's literally 1 over 3 to the 3, which is 3 to the -3, which means that x would just be -3. So that would be enough in terms of like as a working out for the part A. For the part B, we're acknowledging the fact that we've got a negative power here. So notice that AB to the C is A to the BC. And also A to the power of B minus C is A to the B divided by A to the C. So those are the two laws of indices by inspection that we'll need to use. So 64, by the way, is 2 to the power of 6. So 2 to the power of 6 must be 64, which means that we've got 2 to the power of x plus 1 first, and we're dividing by 2 to the 2, the whole thing to the power of y minus 2, which must means we've got 2 to the x plus 1 divided by 2 to the 2y minus 4 on the left hand side. So which means that that is going to give us 2 to the x plus 1, the whole thing, taking away 2y minus 4. That's what the simplest form of the left hand side is. So what that means is that if we look at that to be equals to 2 to the 6 being 64, so we can have x plus 1 minus 2y and then plus 4 to be 6. So all the powers must be the same on both sides of the equation. So the left hand side of the equation, these are your powers. The right hand side of the equation, 6 is your power. So what that means is x minus 2y is going to be 1. The question wants y in terms of x. Since the question wants y in terms of x, we'll just say 2y equals to x minus 1. So y must be x minus 1 over 2. That's part B of the question. So it depends on your order of dealing with the question. You could have times it to the right side straight away, but one way or the other, you still need to like add the powers. So by inspection, that's your question 2B. Question 3, we've got a part A being a sketching question. So we want to sketch a line with a negative gradient, and we also want to sketch a reciprocal graph that's translated 5 units above. So the first thing first, C is a positive constant. Automatically, we know that C is something that's positive. So C is greater than 0. Usually, in terms of Edison question, this line is quite important because later on I can see that we're finding out the set of possible values of C. So of course what that means is we need to include that C is greater than 0 later on as well. But just by inspection, we want a straight line graph for which the intercept is C, and it's a negative gradient where C is above the horizontal axis. So it's negative gradient, so that would be the line itself going downwards. And x-axis, y-axis, and 0, C as a coordinate. And then we also need to have another coordinate, although the question did not specify it. But if it did specify, then we'll need y equals to 0. So when y equals to 0, 3x equals to c, and x must be c over 3. So this coordinate is c over 3 and 0. they want on separate axes, so we don't need to sketch them together. But just so you know, if we graph it, it works as well. So if we delete any graphs on the calculator, we can just do like minus 3x plus any constant c. So let's say a 10, for example. So we can see that we should get a line itself that's going downward sloping line, and it goes through two different points, which is when x equals to 0, y equals to c. When y equals to 0, x equals to c over 3. So that's the first sketch. Let's label it as AI. And then the second sketch, let's label that as AII. Let's do this here. And rearrange this. Okay. So AII, the second sketch, we can clearly see we've got a reciprocal graph. So originally, this is your reciprocal graph, but we want to translate it upwards because it's f of x plus 5 on the outside, which means that the asymptote itself will be an asymptote of y equals to 5. We're going to have a line like this and a line like that, for which we can clearly see there's another intersection point. So this point again is when y equals to 0. So y equals to 0 will give 1 over x equals to minus 5, and x must be negative 1 over 5. So minus 1 over 5 and 0 is the intersection point. We can, if you want, to put them together. So like 1 over x and then plus 5. So we can see we've got this graph. Y equals to 5 is clearly a horizontal asymptote. And then if we want to find out the root of the equation, so highlighting that, we can see that x equals to negative 0.2, which is minus 1 over 5. So that's part A, for which we've got two graphs that may or may not intersect. But the question then go on and tell you that we've got a line. This line and this curve meet at two distinct points. So which means that these are the values for which there is a distinct point. This is the value when they are tangent. There's a tangent over here, and then that's the value when they have twice as well. So obviously we can see that we've got two different sections of intersection. But then they went on and tell you that C is positive, so that means that the line will not go below the axis. The line will only be above, and the line will only be above, so because C will only be positive. So let's go on and look at how it looks like algebraically. So algebraically speaking, we're trying to equate them because they intersect, they meet. So they meet. First of all, they meet, or when they meet, will give you the part B. But they meet at two distinct points. They meet at 2 points. So we're looking for the discriminant, b squared minus 4ac being greater than 0, which then allow us to equate the two different graphs. Minus 3x plus c, we're equating it with the other equation, which is 1 over x plus 5. So that's your starting point. Immediately speaking, we're trying to make it a quadratic. So the only way we can make it a quadratic is to times both sides by x. So minus 3x squared plus cx must be the same as 1 plus 5x. Bringing them all to the left or all to the right, doesn't matter which way you bring. We've got 3x squared plus x bracket. The coefficient of x is 5 minus c, and the coefficient of the constant, 1, equals to 0. So collecting the like terms, we've got our coefficient of x squared, coefficient of x, and the constant terms. We're looking for b squared minus 4ac being greater than 0, for which 5 minus c all squared, minus 4 lots of 3 lots of 1 is greater than 0. So question itself is a show that question. If we expand the bracket, we should get what we want. 5 minus c all squared is greater than 12. Oh, fantastic. We don't even need to expand it yet. It's just minus 12 is greater than 0 as required. So that's the part B. Part C is hence find the set of possible values of C. And since we need to find out what that C is, we're now solving this not even hidden quadratic, sorry. We're just solving this quadratic. Depending on your preference, you can expand, or you can easily just, because it's already in completing the square form, so you can easily just do 5 minus C all squared is greater than 12. So 5 minus C all squared, being a quadratic, is above this line of 12, so it will be the two ends there. So that means that it's either greater than square root of 12, or 5 minus C all squared is less than negative square root of 12. So we've already removed the square root. So that must means that 5 minus C is greater than root 12, or minus C plus 5 is less than minus root 12. So 5 plus root 12 is less than C, or C is less than root 5 minus root 12. So either C is less than 5 minus root 12, or 5 plus root 12 is less than C, so C is greater than 5 plus root 12. So and then also you will need to merge it with C is greater than 0 as an identity. So that would be if you were to do it like non-calculator way, because the question already gave you all the steps. So it's a number line, and let's look at what 5 minus root 12 is. So 5 take away root 12 as a number is already positive. So number line is 0, and then 5 minus root 12, and 5 plus root 12. And we are looking for greater than 0, but also less than 5 minus root 12, and greater than 5 plus root 12. So as a set notation, it must be C is between 0 and 5 minus root 12. This is the first set. And then or the second set, which is C is greater than 5 plus root 12. So that's your set notation. Alternatively, we could have done it using a different way. So let's go way 2. So way 2 would be if we went all the trouble to expand everything. So 5 minus C all squared, if we expand everything, will give us C squared minus 10C plus 25. We minus the 12 is greater than 0. So same way, we've got C squared minus 10C plus 13 is greater than 0. So at this stage, you can easily put in the calculator for the quadratic mode. So 1 minus 10 and then 13. We can clearly see we've got the two roots as well. So quadratic is greater than 0. So C is greater than 5 plus 2 root 3, which is root 12. And C is less than 5 minus 2 root 3, which is root 12. So one way or the other, both of which give us what we are looking for, which is C is greater than 0, less than 5 minus root 12, or union with C is greater than 5 plus root 12. So that's your question 3 over here. Let's pause. No matter which way we've done, we can see that we've got a set of values for C. But what does it actually mean in comparison to the graph that we've just done? So here, what we can do is we can type it in decimals, for example, just to have a quick look of what does it actually mean. So I'm going to type two things. I'm going to type y equals to minus 3x plus C, where C is a positive constant. So let's say C is anything that is from 0 all the way up to 20, for example. So we can see that C is something that varies. When C equals to 0, it passes through the origin. When C equals to 20, it's just like a very big line. We've also already done y equals to 1 over x and then plus 5. What it means is that if you focus on the graph itself, when x equals to 0, automatically we can see that there's two solutions. Based on the solutions that we've got earlier, which is c between 0 to 5 minus root 12. So exactly when c is 5 minus root 12, as a solution of it, so where is 5 minus root 12? So manual and a, polynomial and two unknowns. So we can have 1 minus 10 and 13, right? So when c is about 1.5, we can see that when it's about 1.5-ish, it's a tangent to the green curve. When c is anything that's between those two values, there's no solution, which for the question itself is not what we want, because we want two distinct points. So when c is between 0 to 5 minus root 12, there's two solutions. When c equals to 5 minus root 12, it's a tangent. And at the same time, when c is about 8.46, which is this value, there's a tangent to the upper tail of the reciprocal curve. And later on, it is always going to meet at 2 points. And that's the whole aim of what is actually happening to this question, which is this question number 3. Graphically speaking on Desmos. I'm just going to save this over here. Let's call this question 3. And then put it into the video solutions as well, so that you can click and have a look. Question 4, we've got a cubic equation, a double root at 3, 0, maximum at 1, 4. And we're looking for, on separate diagrams, sketch the equation of f of half x. Alright, so let's say if I sketch the original one, which is x bracket 3 minus x, the whole thing squared, we can automatically see your original graph. Let's do initial. So we can automatically see that your original graph passes to 0, 0, has a maximum of 1, 4 and minimum of 3, 0. So like solve and max will give you the maximum point to be 1 and 4. But we're looking for what happens when we halve all the x values. Alternatively, when we substitute half x into the original equation. So we can just do bracket and close bracket. So x over 2 is the first one. And then the second x is also replaced by x over 2. So we want to, we're focusing on what's happening to this graph itself. When we sketch it, we can see that it is stretched, and it's a horizontal stretch in the x direction. So all the x values originally was 1, 4, but it's got times by 2. So that 1, 4 is a value I can see becomes 2 and 4. So as a sketch AI, let me do it here. It then becomes horizontal stretch, so it becomes 2 and 4. And then this 3 and 0, it becomes 6 and 0. The original point 0, 0 is an invariant point. It still passes 2 at 0, 0. So I can see that max it's 2, 4. The minimum is still going to be 6, 0. But then the root itself, where it passes to, is 0, 0. So this is your sketch, which is part AI. Part AII is a translation 2 to the left. And then what that means is, instead of replacing x to be x over 2, we're now replacing x to be x plus 2. And then the original one, which is 3 minus x, is also replaced with a bracket of x plus 2. So this curve itself, we can see that it will be translated 2 units towards the left. So translated 2 units towards the left, we can see original point, which is 1, 0, 3, 0, it now becomes 1, 0. Original point, which is 1, 4, 2 to the left becomes minus 1 and 4. So maximum point, we can clearly see it's minus 1 and 4. The minimum point is now 1 and 0. And it has also got a root. So how can we find out this root? Because the question wants where it crosses the vertical axis as well. So when your equation is x plus 2, and also 3 take away x plus 2, close bracket, all squared. So when x equals to 0, we have got 2 multiplied by 3 minus 2 and then squared. So that must be 2. So that would be y equals to 2. So which means that your equation will just be what I've just put over here. And let me sketch that. The coordinates are respectively 2 towards the left of the origin, so minus 2 and 0. The maximum point, minus 1 and 4. The intercept point, 0 and 2. And the minimum point, 1 and 0. Joining them together very nicely, f of x plus 2. X-axis, y-axis. So that's part A, II. Put it on the right and call that AII. And then put this on the left and call it AI. Fantastic. Now, more working outs needed for part B. Let me rearranging this nicer first. Okay, part B is that's given that the curve with equation translation upwards f of x plus k. So I'm translating this upward, but it has a maximum point at. So this was the original curve, and we want the maximum point. So I can move it upward, I can move it downward. But more importantly, when we have moved it for a certain freehand drawing, so it's a bit ugly. Anyway, when we move it to a certain translation distance up or down, we want a maximum point at y equals to 0, because a0 meaning that it is on the horizontal line. So this is the new curve that we're looking for. So that means that we have moved it a certain unit downwards. So the original coordinate is 1 and 4. That means that the y coordinate, this distance is 4. So that must means that part B set state the value. It must be k equals to -4. I have moved it 4 unit downward. A must be a equals to 1 because the x value won't change. So that's part B. A equals to 1 and b equals to -4. And that's your answer to question 4. Question 5, we've got a quadratic modeling type of question. It's from a non-calculator paper in the old specification. But nowadays you can easily use your calculator to find out maximum points. So let's do the question first. We can see that we've got a objective function to find out the area, and we've got a criteria, which is the parameter is 120, which means that our aim to start off with is to eliminate one of the unknowns in the question, because we can see that we've got a y, and y is not inside the show that part. So we want to eliminate y, and since we want to eliminate y, we want to make y the subject of the formula. So p equals to 120 will allow you to say 8x plus 6x plus 2y plus 10x, which is all the outside 8, 6, y and then 10. All of them together will be 120. So our aim is to make y the subject of the formula here. Since we want to make y the subject of the formula, we'll say 2y equals to 8 plus 6 plus 10, which is nicely 24. So we've got 120 minus the 24. Making y the subject of the formula, we have 60 minus 12x. So we've got y the subject of the formula, and we can see that we want the area of the shape. Area of the shape is given as the rectangle, which is 10xy, added by the area of the triangle, which is base times height over 2, 8x and 6x, because that's going to give us the base and the height respectively. So half of 8x 6x. That's 10 lots of y, which is 60 minus 12x, added by 8 times 6 times the half, which is 8 times 6 divided by 2. So that's 24x squared, which when we expand, we've got 600x minus 120x squared plus 24x squared. And the difference of 120 and 24 is 96. So yeah, that's fine. That's 600x minus 96x squared, which is as required. Now, what we're looking for immediately is we're looking for the maximum of area. Since it's the maximum of an area, depending on what your preference is, so we can either do completing the square, which is a equals to minus 96, and then x squared taking away 600 over 96, which is 6.25 or 25 over 4 x. So completing the square within this term will give us a equals to minus 96, and then x minus 25 over 8. So half of 25 over 4 is 25 over 8. We square it, and then minusing the square of 25 over 8. So 25 over 8, when we square them, is it 625 over 64? Yeah, then they don't simplify. Okay, so 625 over 64. Immediately, that's the completing the square form. Of course, what that means is if you were to expand it, a will be minus 96 lots of x minus 25 over 8 all squared. And 625 over 4, the minus and the minus cancel out when we expand. And which give us, if we times this number by 96, is 937.5. So positive 937.5. So the maximum area as a point is going to be 25 over 8 and then 937.5. So that's the maximum point of your quadratic. This determines the maximum value of the area of the pentagon and the corresponding value of x, which produce this maximum area. So x is 25 over 8 and a is 937.5. So that's the first way to deal with it, which is completing the square. More advanced way including differentiation. But before we do that, it's a quadratic, so we can graph it. Graphing the original function, which is 600 x taking away 96 x squared, will give us, it doesn't give us the quadratic yet because the axis is not correct. The graph for minus 66 and minus 3 to 3 doesn't show the quadratic. If you want to zoom and auto, sometimes will work. So I can see that there's a maximum point, but the scale is really like, what's the point of scaling it down to like minus 7,000-ish? So we know it's going to be 937. So we can do view window and have an axis of, let's say, from 0 to 25 goes into 8 3 times or a little bit more. So that means that this point there will be 6 point something. So 6.3 will be more than enough. But the y value, let's go from 0 to let's say 1,000. So we should clearly see a nice quadratic. Plus and minus will zoom out once. Solve and maximum, I can clearly see we got 3.125 and 937.5. If you have derivative turned on instead of off, you can even see that solve and maximum will give us dy by dx to be 0 as well. So that's our ultimate aim. What I mean is, when we have learned differentiation, differentiation is probably the shorter method over here. So starting with a equals to 600x minus 96x squared, we can differentiate it. Differentiate it is going to give us dA dx itself. So dA dx is going to be 600 we're taking away 96 times 2, which is 192 x. So we want dA dx to be 0. So 192x will be 600. X itself will be 600 divided by 192. So that gives us 3.125. And since we've got a value for x, we can substitute and say a equals to 600 lots of 3.125 minus 96 lots of the same thing all squared. 3.125 all squared. So we can see that when we do 600x minus 96x squared, we've got what we want, which is a equals to 937.5. And that itself gives us the part B as well, with a different working out, because you learn differentiation in a later chapter. But if you have not learned differentiation, then completing the square will always work. And that's it. That's your question 5. Question 6, we've got vectors. So first of all, we're given 2 position vectors, and they are with respect to the origin, 3 towards the right, 7 downwards, so that's point A. We've got a different point, which is 8 towards the right and 3 upwards, which is point B. The question tells us about vector A to B. So walking from A to O and O to B should give us the vector A to B with respect to the origin. So A to B as a vector must be A to O and also O to B. So the question already gave us the position of 3, minus 7 as a coordinate, and then 8, 3 as a different coordinate. And we want to go from A to O and O to B. So triangular law of vectors will mean that A to O is minus 3 and 7, and O to B is 8 and 3. Which gives us 5 and 10 as a vector. So 5 towards the right and 10 upwards will give us the vector A to B, which is part A of the question. Part B of the question asks us the modulus, which means that we're taking Pythagoras theorem, giving us square root of 5 squared plus 10 squared. Notice that that gives us 5 root 5, which is 5 squared plus 10 squared all square root, which is 5 root 5. And because the question is wanting to ask us about the unit vector in part C, what we can do, for example, is do a Mech vector, and then on the next page there's actually a unit vector in terms of like finding the unit of this vector. But what it means is we want the size of this vector to be 1. So if I press exit twice, and under math I can actually just type a vector. As a 2x1 vector is 5 and 10. What that means is we're looking for this specific vector, would 5 over 5 and 2 would 5 over 5. So what is it actually? It's actually representing the vector to have a size of a 1. So the length of this line was 5 root 5. So when I unitary, meaning that I want a size of 1 for it, which means that all you are actually doing is you're doing part C of the question, 1 over 5 root 5 of the entire vector of 5 to 10, which gives us 5 over 5 root 5, and also 10 over 5 root 5. So as a vector, what that gives us is 1 over root 5, and also 2 over root 5. But if you want to, you can rationalize the denominator and say this is root 5 over 5 and 2 root 5 over 5. And that gives us part C. Part D sets as a bearing the actual direction. So the direction as a bearing, meaning that we've got this vector, and with respect to the north line, we are finding out this angle that it makes with the north line. And what we do know so far is that towards the right is 5 and upward is 10. which means that what we can work out is this specific angle alpha. So make sure that your angle unit is in degree. If not, just do shift manual and then angle unit, because the default mathematical angle unit is radians, although in GCSE you learned degree first. But once you change it to degrees, you can just do trigonometry. So it doesn't matter if you do 5 root 5 or 10 or 5, because we've got 3 sides in a triangle already. Which means that let's just say we do tan inverse of opposite over adjacent, so 10 over 5. So whatever angle this is, which is 63 point, so alpha itself as an angle is, or tan alpha is 10 over 5, meaning that alpha itself is 63 degrees. But as a bearing, because we are measuring from the north, so when we do 90, take away that answer. Although we've got 27 degrees, bearing is 027 as a 3-digit bearing, which we're going to get angle theta to be 90 minus 63. But of course, if you want to, you could have done things like this is a alternate angles in terms of parallel lines. So you could have done like tan inverse of 5 over 10 straight away. And when I do tan inverse of 5 over 10 straight away, I've also got 27 degrees as well. So that would give you your question 6 over here. Part A is a vector 5, 10. Part B is a modulus 5 root 5. Part C as a unit vector, so divided by the length of the line, which is 5 root 5. And part D is a bearing. Question 7 here, we've got a circle geometry question. But the question asks us L and C intersect, meaning that we've got a circle with center 3, 5, but unknown radius R. So we're just going to say that the circle itself is going to have an equation of x minus 3 squared and y minus 5 squared. Equate that to radius squared, meaning that that's your first equation. Your second equation is y equals to 2x plus k. So that's your second equation. When they intersect, of course, that means it's a simultaneous equation. So part A, it would be substituting y into the equation and then trying to expand and simplify. Depending what's your preferences, you can expand the equation 1 first. So I can see that that gives us x squared minus 6x plus 9. And added by y squared minus 10y plus 25 equal to radius squared. And then substitute 2 into the equation. Should give us x squared minus 6x plus 9. Added by 2x plus k all squared. Minus 10 lots of 2x plus k. Which is 10y plus 25. Set it equal to radius squared, but I'm just going to add myself a page first. So I will do it in the blank page. Now, what we do want to see is that we want to make a quadratic, and it's a show that question, so we know what we're trying to work towards. So this part is going to be our answer. So expand and simplify. So far we've got x squared minus 6x plus 9 plus y squared minus 10y plus 25 equate to radius squared. So expand each part using the equation of a plus b all squared is a squared plus 2ab plus b squared. We've got x squared minus 6x plus 9 added by 4x squared plus 4kx plus k squared. Minusing, so 10 multiplied by the bracket itself gives us minus 20x minus 10k plus 25. We know that where r squared is on the left side will give us minus r squared. Collecting the like terms, we've got x squared and 4x squared. So clearly that gives us 5x squared. Minus 6x plus kx minus 20x will give us minus 26x plus 4kx. And then all the constant term, which is k squared, minus 10k, 25 and 9 will give us 34, and minus r squared. So that automatically expand the bracket will give us what we want. So that's part A. Part B, the question went on and say that L is a tangent to C. Since L is a tangent to C, it must mean that we're looking for the discriminant. And more importantly, tangent means meet once, so this means that it meet once. Therefore, the discriminant equal to 0. B squared minus 4ac must be 0. Therefore, we're looking for 4k minus 26 all squared. That's b squared. Taking away 4 lots of 5. That's a. And your c being k squared minus 10k plus 34 minus r squared. That itself is going to be 0. So we've got a new quadratic or relationship between k and r. So which must means that later on we want to like use the relationship. But let's just expand it first. 4 squared is 16. K squared. 26 times 4 times by 2 give us 208, so minus 208k. And then 26 squared is 676. And then here we've got minus 20, so minus 20 lots of k squared. Plus 20 times by 10, which is 200. And I'm just giving myself some space. So plus 200. Okay. 34 times by 20, but with a negative sign is minus 680. And then plus 20 r squared equal to 0. By inspection, it looks like every term is even. It seems like every term is a multiple of 4 as well, because 4 is within this. So let's divide everything by 4. And 16 minus 20 first, if you want to collect the like terms. But it seems everything is a multiple of 4 already. We've got 208 and 200. And we've also got, we want to make 5r squared a subject. So 5r squared needs to be staying on this side. And we're making everything else towards the right hand side. We've also got 676 and 680. So what that means is minus 4 lots of k squared. Minus 208 plus 200 is going to be minus 8k. 676 minus 680 is going to be minus 4 as a constant, then plus 20k r squared equal to 0. So it looks like when we bring everything to the right, divide everything by 4, we're going to get k squared plus 2k plus 1. So that's a perfect squared equals to 5r squared. So if you need another step, we can do things like 20r squared equals to 4k squared plus 8k plus 4, which means that we have got 5r squared being a perfect squared, k plus 1 all squared. P itself must be equal to 1. Therefore, since we've got P is a constant to be found, and 5r squared equals to k plus 1 all squared, we can take a look at part C. So, giving myself some space, copy, and then move it over here. Alright, here we've got part C of the question, which threw off a lot of people. Now, in part B of the question, we just found out what 5r squared is. So it's a relationship between r and k. And it so happens that they gave us a particular circle with center of 3 and 5, and a line which passes to point A. Point A is something that we can find out, because that x is the intercept where x equals to 0 and y equals to k. So that's a coordinate itself, 0, k. Figure 3 shows the line which cut the y-axis at the point A and touch the circle at the point B. So it's a touching point. And they gave us, in particular, the length of A to B, which is 2 radius, 2r. And the circle itself has a radius r. So those two are the two things that's given. So we can, I think the only thing we can do pretty much is, because it's a right angle triangle, with a length of 2r, a length of r, it kind of left us no choice, apart from attempting Pythagoras theorem. So a to x as a length must then be 2r all squared added by r squared, square root of it. So 4r squared plus r squared, square root of it, and must be 5r squared, square root. And it so happens that that was what we have already showed at in part B. Which means that if you focus on what we've got in part B, which is 5r squared to be x plus 1 squared, k plus 1 squared, we already have a coordinate. The coordinate is a to x. So I think what we can, the next thing that we can do is we can find out the length of a to x in terms of k. So a to x as a length in terms of k will be distance formula, so 3 minus 0 all squared, and also 5 minus k all squared, square root of that. So that's change in x all squared plus change in y all squared. Expanding the bracket will give us 3 squared is 9, 5 squared is 25, 5 times k times 2 is 10k, and k squared is k squared, or square root. Minus k times minus k is k squared. Expanding and simplifying, we've got k squared minus 10k. 25 plus 9 is 34. So what that means is that square root of 5r squared must be square root of k squared minus 10k plus 34. So we've got a different relationship of radius 5r squared. 5r squared is k squared minus 10k plus 34. Which, as a conclusion, comparing to what we've done in the earlier part, what we've got is then k squared minus 10k plus 34, which is what we've done so far, which is 5r squared, must also be the same as 5r squared. So we've got two equations of 5r squared. So we can equate it. K squared minus 10k plus 34 must be the same as k squared plus 2k plus 1. So those are the two different ways we can write our k, which allow us to work out the value of k. K squared cancel out, so 12k on the right hand side and 33, isn't it, on the left hand side. So k will be 33 over 12. Does it simplify? Yeah. 3 is a common factor, so 11 over 4 is the answer for part C of this question. Question 8 here, we've got a velocity time graph or speed time graph type of question. So we're given that we've got two small children and A and B respectively. They running 100 meters race, which means that the area of your speed time graph for both of the graphs need to be 100. So the question gave us they both start from the west, and which means that they both finish at the same time as well. So that means that here you've got two different graphs. The first graph A accelerate at point 8, so that would be the gradient of the graph up to a height of 4. So you've got kind of like as a triangle where the height is 4. You don't know what the x is, so 4 over x must be 0.8. X itself must be 4 divided by 0.8, which is 5. That would be the first point of core, And then it then maintained this speed until I finish the line, which means that you've got a acceleration stage and a constant speed stage. That would be everything you know about A, and then you finish it. So area under the graph is roughly 100, or exactly 100, sorry. So that's what we know about A. B though is a steeper acceleration. 1 is a steeper line. But then, if you think about it this way, so first of all, 1 needs to be steeper. So if we were to draw it together, if we do it like that, and horizontal, then the two graph doesn't give you the same area, because the area of both of the graph needs to be the same, which means the only way you can do it is to have a faster acceleration but slower top speed. So it gets quicker, it gets to the top speed quicker, but the top speed is slower, so that the two pieces of the area is still the same. And we don't know what that top speed is, but we do know that t as a value will be less than 5, because this value over there is 5, which means that we need a steeper gradient all the way up to here, and I'm just going to call this point t, and just do a horizontal line, because they stop at the same time, or they finish at the same time, which means that when you cross the finish line, you're going to have a speed. We don't know what that speed is, but if you think about the gradient being 1, automatically what we do know is that it would have a rate of change of t and t. So that must means that the when you make a nice axis, which is speed and time, what we do know is that the top speed is 4 and the top speed is t. Now what that automatically means is that we've got our speed time graph, and just making it bigger, and also we have got the second one to be b. So we want the two area to be the same, and which give us a area of A, and we've also got an area of B, and they're both 100. So let's label the sides of your trapeziums. We do know that they finish at the same time. So if we focus on the first trapezium, we've got this space to be 5, we've got the height to be 4, but we don't know what the total base of the trapezium is. So, but what we do already know is that it's 100 in terms of the area of the trapezium. So let's call this unknown x. So this part is also going to be x. So the area of the is 100 of the trapezium, and if I call this length, which is the same as this length, x, that means that it took you the entire length to finish the race. That must means that x plus 5, that's the area of the shape, divided by 2. The whole thing times by 4 is going to be 100. So one equation, one unknown, will allow us to work out x. X itself is going to be 2x plus 5 times by 2 equals to 100. So 2x plus 5 is 50, 2x is 45, and x must be 22.5. So the time needed is going to be 27.5, because that's the entire length of 27.5. And just reading the question here, sketch on the axis, we have done that. Speed time graph for each child from the instant they leave to the instant they cross the finish line. Part B is the time for A to finish the race. We have done that, 27.5 seconds. Part C asks us to find the capital T, for which the time is the time to finish the race for particle B, or for children B, which allow us to say that for the other shape, for the other trapezium, what we do know is that the area is also given as 100. So what do we know about the shape? We know that this part is capital T, and this part is also capital T, which means that the entire part, because the length of the time is the same according to the question, they finish the race at the same time and start at the same time, finish at the same time. Therefore, that length here and that length here must be 27.5 minus t. So we can set up the equation in terms of the area being equal to 100 again. And this time we've got 27.5 as the total. We're adding it by 27.5 minus capital T. The whole thing divided by 2, area of the shape, and the whole thing times by t. That's going to give us 100 again. So what does that give us? 27.5 times by 2 is 55 minus t. The whole thing times by t is, if we put the 2 to the other side, instead of dividing by 2, let's call it 200. So it looks like a quadratic. 55t. Excuse me, mouse not working. Let's pause. Okay, continue. So expanding the bracket, we've got 55t minus t squared is 200. So it's a nice quadratic. T squared minus 55t plus 200 equal to 0. Now notice that capital T is what we want to find out. So equation and then polynomial with 2 unknowns. We've got 1, negative 55, and 200 would give us a value for capital T. Which one is a sensible answer? Is T going to be 3.915, or is T going to be 51.084? Because capital T needs to be less than 27.5, because I was accelerating and then maintaining the speed. That must mean that T equals, so we need to reject the 51, and T equals to 3.915. That's the capital T that part C was asking us to do. Part D sets find the difference in the speed of the two children as they cross the finish line, which means that the two top speed is the difference between 4 and T. So 4 take away 3.915 is going to be the answer to part D, because we already know that that's the top speed of each one. So 4 take away 3.915 will give us 0.085. Which is the final answer for part D. Find the difference in the speed. So in terms of a unit, this is 3.915 in terms of seconds. Oh no, this is already a constant, because they say t seconds already. So t don't need to be a second, but the difference in the speed needs to be 0.085 in terms of ms minus 1. So that's the answer to question 8. 0.085 ms minus 1. Question 9, we've got a vertical motion. So it's a favorite of Edisel to give questions in terms of letters. So particle is projected upwards, initial speed is u, and at a capital time t, the maximum height is capital H. What that means is we definitely know the maximum height with respect to the point A, which is the gain in height in terms of point A. we will have a gain in height of h meters. So we're looking for the kinematics SUVAT with respect to the point A, where the maximum is at h meters above A. So S will be the gain in height. So if I call this your zero displacement, then gain or anything that's above would be positive. So that means that if you look at the sign itself, h is going to be, if we take upward as positive, the S would be capital H, that's positive H. U itself is also going to be positive because I'm initially going upwards, and V itself is going to be 0, and acceleration is against the direction of motion, so that's minus G. So we've got the signs for which G is opposite to H and U, and then what else have we got? We want to find T. So T equals to a question mark. And we want to find T in terms of U and G, which means that we're looking for the V, U, A, and T in terms of a equation of motion. So part A, we've got V equals to U plus AT. Substituting what we want, we've got 0 equals to U minus G lots of T. So U is going to be G lots of T. But capital T is the time in specific to this motion, which means that capital T is going to be lowercase u divided by lowercase g. So that's part A. Part B, we're looking for the height. So we don't really need the time this time, because we're looking for S, U, V, and A. So that must means that we want to have V squared minus U squared equals to 2AS for our equation of motion this time. V is 0, U squared is just U squared, 2 lots of minus G times by the S, which is capital H, and we want to make capital H the subject of the formula. In our case, that gives us U squared, and the negative cancel out, so U squared equals to 2G capital H first, and H must be U squared divided by 2G. So that gives us part B of the question. Part C tells us that initially part A, or particle A, is actually not on the ground. Initially, particle A is actually 3h above the ground. So that means that this height was 3h, and the floor is here. Notice that what we do want is find out the time from the instant of projection. So this particular instant, I go up and then I go back towards the floor. So this particular point. And you already know the time from 0 to maximum. So it's entirely up to you if you want to go just from the maximum and find out the time. With that, the S would be minus 4h. Alternatively, you can look at the entire journey straight away. Then the S will be minus 3h. I think what we can do is we can do both. It's a 4 marker, so we're probably solving a quadratic here. Let's start. So here we've got part C. Let's call that way number 1. And I want a clean page. So instead of this, insert a blank page. Yeah, there we go. So here we've got way number 1, which is S to be minus 3h, upward to be positive. So we can have for the entire journey, so that is this particular journey, the whole thing downwards, we've got this part. U is upwards U, A is downwards minus G, T is what we want to find out. and we don't know about the velocity. So we're just solving an SUAT quadratic. S equals to ut plus half of at squared would give us minus 3h equals to ut minus g over 2 times by t squared. It's a quadratic that we can solve. H is already found out to be u squared over 2g. So u and g are just constants. So g over 2 t squared minus ut, and then minus 3 lots of h equal to 0. But we know that that's g over 2t squared minus ut minus 3 lots of u squared over 2g. So it's a quadratic that we know how to solve. Definitely we can use quadratic equation. So that is t equals to, because it's a quadratic in terms of t, that we want to find out whatever t is. Minus b, so u plus or minus b squared minus 4ac. So that's u squared minus 4 lots of g over 2 times by minus 3u squared over 2g divided by 2a, which is g. Quadratic equation, and let's see what's simplify, because g and g definitely cancel out. And what are the numericals? Numerical number in here. So 4, 2, and minus 3, and then over 2. So we can clearly see that the negatives cancel out. In the calculator, we can have 4 divided by 2. So that's 4 and then over 2. And then times by 3 and then divided by 2 again. We can see that that simplified to 3 on itself. So it's u plus or minus u squared plus 3u squared square root divided by g. So that would give you u plus or minus 2u when we square root 4u squared divided by g. So time is positive, therefore t is going to be 3u over g. Do they want it in terms of t, or do they want it in terms of u and g? They want it in terms of t. So u over g is capital T, which means that that is going to be 3 lots of t. So that's, if we do it using way number 1, considering the journey from A all the way downwards. Way number 2, you can just do it from the highest point maximum, and you should get the same answer no matter what. So consider way 2 from maximum to floor. S itself is minus 4h. U itself is 0 because I'm looking for the maximum downwards to the floor. Same thing, A is going to be minus G, or depends if you treat the downward as positive, then it will just be positive 4G and positive G. So that may be easier to do because everything is positive. And SUA, T is what we want to find out. So it's still kind of like as a quadratic. S equals to UT plus half of AT squared. And 0 is gone already, so that's quite nice. So it will just give us 4h equals to G over 2t squared, which is 4 lots of capital H. Capital H is giving us u squared over 2g equals to G over 2t squared. I think way 2 is easier, but the problem is you need to add on to the time in part A. So that gives us 2u squared over g equals to G over 2t squared. So bringing it to the other side gives us 4, because 2 to the other side gives us 4. U squared over g squared equals to t squared. G over g is g squared. So of course that gives us t itself is 2u over g, which is 2t. and that's fine because we can clearly see if we add on both stages. So that took t and that took 2t, so the total time is very nicely 3t. And no matter which way you dealt with, that gives you the same answer. So that would be what we've got here so far for the question 9. Question 10, we've got a statistics question. It's a sampling question. Names of 720 members, so we already know the sampling frame, of a swimming club are listed alphabetically. So we already know that they are listed alphabetically. So this is a fact that's given, which means that when you talk about advantage and disadvantage, we need to know that this is already a fact that is already listed alphabetically, which means that, for example, siblings, for example, could be sticking together. So like if me and you are sibling, our alphabetical names will be similar, hopefully, which means that me and you in a systematic sample won't be chosen at the same time. We know that we want to pick 40 names, and the names are numbered from 001 to 720, and they describe the systematic sample for you, which is a number between 001 and W selected, corresponding name and every X name thereafter included. Alright, so if I were to pick one name here, another name here, another name here, and another name here in each and every group, and in total I want 40 names. So how many lots of 40 would go into 720? So 720 divided by 40 will give us 18. So there's 18 names in the first group, 18 names in the second group, 18 in the third group, 18 in the fourth group, and so on. In total, there are 40 of these. 40 of 18s will give you 720, which means that the W and X, W itself is a number between 001 and 018. The value of X, I'm picking every 18 names, and then I can stop, and that would be what we call systematic sampling, which means that X would be 18, every 18 name thereafter. Find the probability that first name and the third name is they're both included in the membership book. So like we said, because we're picking every 18th name, so if I pick the first name, then the next name that I pick will be the 19th name. So therefore, I cannot pick both the first name and the third name. They're mutually exclusive events, which means that the probability will be 0. Let's just use 0 like that. The next thing is we have got a disadvantage and also a advantage. In this particular case, what would be a advantage and what would be a disadvantage? We cannot talk about things like we already know that it's listed alphabetically, so we're not comparing it with any other sample. But if there's 720 members and we're just picking every 19 name, every 18 name, so a quick advantage would be like, it's quick and easy, simple to follow. So quick or easy. Because we have already got all the names, we've already got a list of names already. So quick and easy, simple to carry out. Let me also take a screenshot of the marking scheme and see what it's saying. So that's advantage. But an obvious disadvantage is, like we said, the first name and the third name cannot be picked at the same time. So because the alphabetical list, so it's not random. So there's some names cannot be picked. Some names cannot. Some names, for example, first and the third name can never be put together. So that would be kind of like as a disadvantage. And let me take a quick screenshot on the marking scheme and see what they say. And put it here. Pause. Alright, marking scheme is right here. And it seems that they're talking about similar things that we said. And advantage is quick and efficient or equivalent. It's suitable for a larger sample, and it gives a good spread of the data. Disadvantage is alphabetical list is probably not random. And we also can see that requires a sampling frame is definitely 0 because we already have the list. So that would be part D of a sampling question, question 10. Question 11 here, we've got a Venn diagram probability question. In the Venn diagram, we've got 3 different events, and they are respectively A, B, and C. So A, B, and C. P, Q, R, S, they are probabilities, like P, Q, R, and S. Each one are probabilities. Events A and C are independent, and probability of A is given as 0.65. So that must mean that probability of A multiplied by probability of C is the same as the probability of A intersection with C. Probability of A is given as 0.65, and probability of the intersection is given as 0.13. And C itself, we can add it up. Everything that's in the C circle, that's 0.13 plus R. And as a multiplication, as a multiplication, we're looking for R itself as a number. So we can just do 0.13 divided by 0.65, and then take away 0.13, will give us R equals to 0.07. That would be the value for R. Part B. Part A is stating which of the 2 events are mutually exclusive. So 2 circles that don't touch. We can see B as an event and C as an event. They are mutually exclusive. The intersection of 0. Now, in the part so far, we work out R, and we are given that probability of A is 0.65. So this particular region is 0.65, including the 0.13. And the bit on the outside, which is 0.07, is letter R. But we do know that there's something on the outside as well. Question told us that that would be letter S. So that must mean that because all the probabilities should add up to 1, we have got 0.65 plus 0.07 plus S. That will give us 1 because sum of the probability equals to 1. S as a number would then be 1 take away 0.65, take away 0.07, which is 0.28. And I believe that's what the question asks us to do, which is find the value of R and find the value of S. So that's question 11, and we've done that. Just highlighting the answers, and then press stop.